Hello, I'm happy to show you our previous study. We studied about interpersonal coordination during walk and talk. The name of the paper is a Rapport and Gait Monitoring System using a single head-worn IMU during walk and talk. I will shortly introduce what is a rapport and our motivations. Methods, results, conclusion, and reference will be following. Walk and talk is very common in our daily life. You can see it everywhere when two or more people walk together. They respond to others' talk, actions, and facial expressions, and etc. They nod and look at each other depending on their actions and talks. During walk and talk, we might build rapport, trust, and friendliness. However, some people are not able to do these kinds of social activity. They cannot catch others' actions and social cues, so that they cannot respond to it. We can call them mind blindness or autism spectrum disorder. Our motivation is to help people who are not good at socializing and not good at reading others' social cues. We would like to design an intervention walking and talking outside instead of in office or the labs because intervention outside can open their mind faster and easier. For this, we would like to use measurement and feedback mechanism. This is like an intervention with pedometers, which count steps and give feedback to users. The number of steps is good information to maintain their physical activity. For social activity, as the first step, we focused on head movement, which has a lot of social cues, and it can be easily measured by head-worn devices like earphones. From Ticker-Stagnant study, we found three components for rapport measurement: positivity, mutual attention, and coordination. To measure these three components, we can observe hand gestures, body postures, and facial expressions. In this paper, to find a simple solution, we focused on head movement. We measured the number of head nods as positivity. For mutual attention, we measured head orientation, if they are look at each other or not. In terms of coordination, we checked they look at the same direction or their gait patterns are synchronized. Of course, we have to consider not only the simple dodge motion events but also other environment and context to know about the level of rapport because human social activity is really complicated. Nevertheless, detecting simple motion events can be a good reference, especially in the beginning of building rapport, usually when there might be no context. We asked two participants to walk on the 400-meter track in our
Before,
sports campus.
isn't it? Yeah.
Both
Okay.
participants walk
Okay,
alone
Christian.
and then walk together.
Um,
This is the
what
video
I've
at the
said
beginning
in the
of
first
walking
one.
together.
Oh, it's for me. It's a pleasure to participate in this study because if you look on the left, you see a really great field of sand.
This is a short moment. After that, they walked 4 minutes for one lap of the track. First, we detect and count node motion. We divided obvious node and subtle node with a threshold of T1 and T2. Of course, head movement is noisy, so that 1 second window Rootman squares data were observed. The horizontal axis tells us a temporal factor. This is the sample number. That is the same as frame number at 60 Hz. The vertical axis tells us angular acceleration, degrees per second square. The monitoring system counted 50 out of 53. For head orientation, we define the head angle between the walking vector and head orientation on the global coordination system. Two walkers have different head angles, theta 1 and theta 2. These angles like being observed by the transverse plane. Using head orientation, first we measure the mutual tension at theta 1 minus theta 2. The range will be plus minus 180 degrees. Here it was normalized plus minus 1. When you look at the graphs, the horizontal axis is the sample numbers as a temporal value, and the vertical axis shows the normalized value. The upward direction is positive, meaning looking at each other. Downward direction is negative, meaning looking at different sides. So in this period, they look at each other 7 times. It is easy to count them. Secondly, we measure the coordination of head orientation. It is divided into 3 parts in the range of head motion. We set status values. Looking at the right is 1. The left is minus 1. Looking ahead is range of plus minus 9 degrees is 0. The graphs are results of absolute mean of the status values. When you're looking at each other or different sides, results in 0. One participant looks ahead and another looks left or right will be 0.5. When they all look at the same direction, right or left results in 1. We note after 20 seconds, one participant said, "Look at the left." Then they start looking at the same direction. We can find it after 20 seconds. We also measured gait coordination. The gait cycle, there are double support periods when both the left and right foot are on the ground. We set 1 when it is the double support period. If not, it is a 0. So two participants generate 2 different binary signals. The coordination coefficient between 2 binary signals result in 2 graphs. The left one is when they walk alone, whereas the right one is when they walk together. We can see the phase locking periods in walking together. The coefficient values is also higher than the left graph. That means their walking patterns are correlated and synchronized. So now we reach the conclusion. Using a head 1IMU only, we simply measure rapport with head nodding, head orientation, and gait patterns simultaneously. We measured 3 components of rapport: positivity, mutual attention, and coordination. For rapport analysis, we need environment and context information as well. Nevertheless, head 1IMU detects meaningful events automatically and reduces time-consuming tasks by increasing efficiency in rapport analysis. In the future, it will help technology-driven intervention for people who have difficulties in socializing, for example, people with ASD. So click here. Here is the reference. Thank you for your attention.